Okay, there are steps to follow, like a mental checklist when factoring. If you wanted to make one, that's great. But this flow chart that we have here is just amazing for, for how to factor. In fact, you might want to use it for today's lesson. It might be something that really helps us out. Or maybe you've done so much, maybe I forced you to do so much factoring that you might just be really good at it right now. Now, this lesson could be completely useless to you because you're already that good, or it might be like, oh, okay, that's kind of interesting. So it says here, identify the factoring strategy you would use to factor each expression. So when they say factoring strategy, what they're talking about is like, is this a difference of squares? Is this a simple trinomial? Is this a complex trinomial? Or is this might be a group factoring one with 4 terms? So if we have a look at this A, when you look at A, what do you notice about this quadratic expression, 49y squared minus 9? What do you notice? They're both square terms separated by a subtraction symbol, right? So we know we're thinking difference of squares. Absolutely. If you're thinking difference of squares, that's great. In fact, because it's only 2 terms, you should have sent your spidey sense should have kicked in and been like, okay, difference of squares, here we go. Is it? And you confirm it. You say, okay, subtraction sign, lovely, square term, and you're like, all right, I'm ready. Now, how about this one here? 6x minus 15y minus 21z. Well, what would you do in this situation? How might we factor something like that? What's the only factoring method that'll work for that one? Does it look quadratic? No, it doesn't really look quadratic. It's just some sort of expression. How do we factor that? Well, maybe we could just use a common factor, right? Like each term is divisible by 3, right? We'll say each divides evenly by 3. Is 3 the, yeah, I think it's 3. Alrighty. How about this third one here, C? We got x squared minus x minus 30. What type of quadratic expression is this? It's 3 terms, so we're thinking 3 terms, like, okay, 3 terms. What are we thinking? What are the 2 things that maybe come to our mind? It's either going to be the simple factoring, like the short factoring, or it's going to be the complex factoring, which is like the long factoring. So which one is it? And how do you know? Yeah, it's simple. How do you know? Simple factoring, yeah, I like that. We'll say a equals 1. The a value here is 1. It's 1x squared. So we know we can just use the method that we called sum and product, right? 2 numbers that multiply to negative 30 and add to negative 1. Okay, how about this next one, part D, 4x squared minus 12x plus 9. When you see this trinomial, what's going on? What factoring method do you think here? Complex, yeah, how do you know? Yeah, complex factoring. A does not equal 1. Now, I got to let you know, this is actually what we would call a perfect square trinomial, but at this point in our factoring, I don't really want you to know that. I just want you to factor this as you would a complex, and we will factor this in the next slide, and you're going to see how it comes out to play. A is not 1, and it cannot be common factored. Okay, how about the next one here? 20x squared plus 11x minus 3. Well, 11 is prime. There's no common factor here. This one also is going to be complex. Complex factoring. A does not equal 1. And this last one here, there are 4 terms. And when there's 4 terms, we use that group factoring method. Right? We will group the first 2 terms, factor them, and then group the second 2 terms and factor them. So far, so good? Great. Now, let's go ahead and factor each of these. I know, it might have been a while, and this is it. Maybe on the next slide, what I'll do is I'll show you how to factor complex trinomials in a whole brand new way. But for right now, let's just use what we got. Okay, difference of squares for this first one you mentioned. So I'm thinking to myself, all right, well, what's the square root of 49y squared? I think it's just 7y. And what's the square root of 9? Is 3. So what we do is we throw them in brackets. One bracket with a minus, one with a plus. And since the first term is 49y squared, and its square root is 7y, 7y is going to go first. And since 9, the square root of 9 is 3, and that's the second term here is going to be 3. So it factors into that. 7y minus 3, 7y plus 3. And that was yesterday. That was the other lesson. Difference of squares. Okay, part B. We mentioned that each of these have a common factor of 3. So we can divide this by 3, divide this by 3, divide this by 3. And we have to make sure to keep that greatest common factor out front. And we're left with 2x minus 5y minus, is it 7? 7z. I do my z like that, sorry. I don't want it to look like 72, so I do 7z. Put the little line through the z. And then can we go any further? No, I think that might be it. Okay. Good. Next one here, we mentioned this one was simple. So we're looking for the a value equals 1. We love that. Two numbers that multiply to negative 30 and the same numbers add to negative 1. Right? They multiply to the c value and add to the b value. And what might these numbers be? 5 and 6? 5 and 6 in some sort of way? Is it negative? No, negative 6, positive 5. Has to be that one. It could not be the opposite of that. This will factor into x minus 6, x plus 5, and that's the short method of factoring, and we love that. That's just great. It's amazing. Now this one here, a is not 1. A is certainly not 1 here. So what we're going to do is, first I'm going to have to pull out a calculator. Two numbers that multiply to a times c, right? A times c, and then they add to b. b is negative 12. A times c is 4 times 9, and it's 36. Like I said, this one is actually a perfect square. You don't know that yet, but watch how this one works out. Multiplies, I think it multiplies to 36. Right away, what comes to my brain is 6 times 6. Yeah? And that's actually it. So it's going to be negative 6 times negative 6. So what we do is we break up that negative 12x into minus 6x minus 6x. And then we group factor each side. So we're going to common factor here. I think we can take out a 2x, and we're left with 2x minus 3. And over here we can take out a minus 3, and we're left with 2x minus 3. Yeah? Okay. And then we take out the common factor of 2x minus 3, and we're left with 2x and minus 3. Interesting. We can actually go one step further, and we should always go one step further with these ones, and kind of state this as 2x minus 3 squared. Now, if you're curious as to why this might be known as a perfect square trinomial, well, I looked at the first term, and it's square rootable. Yeah? 4x squared, square root is 2x. The 9, square root of 9, is 3. The b term's got a minus on it. Now, if that b term wasn't minus 12, it would not work. But what we do know is that the b value is equal to 2 times the square root of 4x squared, which is 2x, times the square root of 9, which is 3. So if we're doing like 2 times 6x, which is 12x, and then that's how we would understand that this is a perfect squared trinomial. And that's what I didn't want to get into. But in case you were curious, that's what went through my mind at the speed of light. But not important for us to really like know and practice something like that, because we could just treat this like any old complex and life is good. Okay. This one here. Two numbers that multiply to negative 60 and add to 11. Is that what we're dealing with? Multiplies to negative 60. I'm thinking 15 and 4 in some way. 15 and 4, yeah. So it'll be positive 15 and negative 4. And that one's going to equal 11. So we have here 20x squared. I think I'm going to put the plus 15x first, the minus 4x second. When we group factor, I think we're going to take out a 5x. And we're left with 4x plus 3. And then this is a strange one for the next two terms. We're actually going to just common factor out a negative 1, which feels really weird. And we're left with a 4x plus 3. So we common factor out the 4x plus 3, and we're left with 5x minus 1. Great. We've done a lot of these. And this group factoring will not be a surprise at all, especially when we've been doing this for a little while now. We have been. So I think in the first two terms, we can take out a 3x, and we're left with x plus a. And then in the second, we can take out a negative 2, and we're left with an x plus a. And then, because they're both x plus a, we can go one step further, common factor out the x plus a, and we're left with 3x minus 2. So the reason why this particular lesson is a little bit different from the other day is because I don't actually explicitly state the factoring method you have to use. You just are going to get so comfortable with it that you're just going to know and understand. Because moving towards grade 11, they'll kind of never tell you what factoring method to use. They'll just say factor, and that's by the end of grade 10, that's kind of where we want to be around. Yeah? Now, in case you're curious, there's a beautiful way to factor trinomials. And I just want you to look, and if maybe it's not for you, then it's not for you, that's great. So let's say factoring, we'll call them complex trinomials. Using the magic X. Now, like I said earlier, this is a beautiful method. It's really hard to see the math here. But I think after a ton of decomposition, we're gonna really appreciate this method after doing a ton of decomposition. So can someone give me or maybe should we use one of these? One of the complex ones here? Let's go ahead and do something like that. Which one was the complex? Was it here? 20x squared? So can someone read that to me so I don't mess this right up? Let's just say the question says factor. We're like, okay. And then they give us a question. They're like, okay, number 1. And it's 20x squared. Catalina, what is it, 20x squared? Plus 11x minus 3. Yeah? So check this out. You might really love this or you might really hate it. But either way, check it out. It's really cool. So we draw this x. We draw this x. And the reason why we do it is because this is the one we're going to multiply to, and this is the one we're going to add to. So we're going to multiply to negative 60, right? Because that's a times c. And then we're going to add to positive 11. And that's just our b value. Remember that? So it's very similar to our chart that we're used to making. Like we used to do this over here, a times c and b, right? And we used to figure it out. But then a lot of you got really good, and you don't even really need the chart because you just know the answer because you're really good with your multiplication tables. So what did we say the answer was for this one in particular? We said the two magic numbers that work here were 15, positive, it doesn't matter where it goes. So positive 15 and negative 4. Those are the two numbers. Yes? Now here's where the magic happens. When I say magic, we're kind of taking the math right out of this. But it is cool and it does work. What we're going to do is now divide each of these magic numbers by this A value, which sounds so weird. But check it out. We divide this by 20, divide this by 20. Yeah? Now, let's reduce the fractions. What is 15 over 20 reduced to? I think it's 3 over 4. Is that right? 3 over 4? And then this one over here reduces to negative 1 over 5. Is that what it is? Negative 1 over 5? Probably wondering, why are we getting into fractions? I know. But check this out. Here we are, the grand finale. We're actually done. It's going to factor into 4x plus 3, because it's a positive 4x and a positive 3. And this one factors into a 5x minus 1. Thoughts? Like, it's great. It's quick. It's pretty fast. But again, like, it's a little strange because, like I said, it's a huge corner cut. So remember in grade 9 math how we bugged you to balance the equation. We're like, whatever you add to one side, you have to add to the other. But then, I know, especially there's a lot of us in here, we got so clever with the equation solving. You just brought it over to the other side and changed the operation, right? Remember that? You bring it over. And we do that in grade 10 a whole lot. And that's kind of a corner cut. Truly is. That's a corner cut. Just like this. This magic X, it's a pretty big corner cut. Well, we do like it. We will accept it every single time. But if you like it, it works. If you don't, I'll leave that up there. And folks, that's it. That's all I got for today. There's some homework stated at the end here. I'm sure you knew that. Not a ton, because if you complete this homework, you can continue working on the Factor Mania thing. Yeah? Great? Thanks.